So Ben Smith joined APL 5 years ago after spending a decade as a medical and scientific illustrator. Ben's journey as a 3D artist began as a kid in the 90s, making landscapes in Bryce. Oh, Bryce. And View. In college, he trained in Maya, then moved to Cinema 4D when he joined a medical animation company. During this time, he heard rumors of Blender and began learning to program on the side. Once at APL, Ben asked around about VR projects and eventually joined teams using Unity to build 3D environments. His passion for texturing and lighting led him down the rabbit hole of game engine lighting, which turned out to be a much more complicated and frustrating topic than he ever thought. Today, he'd like to share some insights gained along this journey. Please welcome Ben Smith.
All right. Testing. Can you hear me? All right, that sounds good. Thanks for coming, guys. I'm excited to be here. Excited to talk about lighting, a little bit of a departure from the normal subject matter, but I think we can all use a little bit more beauty in our projects. So, let me get after this. Check out these gizmos. I pulled these out of Unity. What we have up here is a reflection probe on the left and light probes on the right. Now, I know that quite a few of you probably open your scene and then immediately delete these. But I wanted to not go into like what buttons you press to make it happen. Today it's more of a general overview of how they work and what they do. So this is a small sample scene. I made a little shoebox diorama with a red and blue floor. You're going to see this again later. It helps to show how reflected light bounces off of objects. But just in the program, this is kind of what you would see. You would have your, a light somewhere, and then you would have this little triple dot if you got a light probe, and your little sphere thing if you have a reflection probe. If you were to click on them, you got this kind of thing pop up. So over on the left, all of those little yellow nodes are capture positions for the light probes. And on the right, a little less scary, you have a mirror ball and a bounding box. So the general idea here is that one of them is like a 360 camera. That's the reflection probe on the right. And then the other one is more like an old school photography light meter. I mean, most people have it in the camera, but I remember when, people would walk around with a handheld one and hold it next to your face and then next to your shoulder while you were sitting there waiting for a portrait. So that's more how the light probes work. But it's not just light intensity, it's also color info. First, I want to review some art terms. I do have some of my colleagues from the comms department. So you guys will probably be familiar with most of these. But just to review, we're going to be talking about ambient occlusion, bloom, screen space, reflections, global illumination, direct light, and reflected light. I'll just sort of be touching on them all, but I wanted to show some examples so that we're all on the same page. So let's start off with a little example scene here. So I've got this little, stage that I made. It's very basic. There's nothing here except for a bright directional light coming in from the left through a window. Most of you, when you open Unity or whatever your game engine of choice is, you will have a sun, or if you're doing the indoor scene, a spotlight, and then you can start putting objects in. But your lighting is pretty much limited to this. Stark shadows. I cheated a bit and added a little ambient light so that the shadows weren't just straight black. I wanted to be able to see something. But in general, this is what you have. One thing I want to point out, are those objects even sitting on the stage? Can you tell? What if I said they were all hovering 3 millimeters above the floor? You don't know. So the first thing we're going to touch on is ambient occlusion. I don't know if you noticed, but now there's a tiny little shadow below everything. This is not actually a shadow made from the lights. This is a post-processing effect that is created when geometry is very close together. And it's an approximation of what you see in real life. It's very common in 3D renderers and really helps give the human eye depth and proximity information. Now, we've added some bloom. Some people will, maybe argue bloom is superfluous, not necessary. You can see that there's a little bit of a glow around the bright spots between last slide, this slide. So one of the reasons that we add bloom, it's a post-processing effect. What it does is it helps give the viewer information about how bright a light source is. I'm assuming most of you people are earth-born mammals whose eyes have a certain upper tolerance for the amount of incoming photons bright lights hurt to look at. So screens, thankfully, don't approximate the brightness of the sun or the filament of an incandescent light bulb. Or it'd be like those old school like spy movies where they put the torture device on. It's like, if you open your eyes, you'll go blind. So what we do is add a little bloom, and when certain things are really bright, the glow effect helps give the viewer that sort of innate understanding that what they're looking at, it's pretty intense. Now, what I've done is I've added screen space reflections here. This is, in some programs, this is a separate thing from global illumination. In other programs, it is all blended in together. The wall in the back is now starting to reflect a little bit of the light. You can see a reflection in the sphere of the bright spot behind it. You can also now finally see that there is some of the blue box reflected in the horse statue. That horse statue now actually looks like it's polished and smooth because you can see something in it. And I believe that my next one is going to be where I turn on the global illumination. So this is where, if you were in Unity or Unreal, this is where you would have baked your lighting and really made the scene come alive. It's going to calculate all the light rays that are bouncing around. It's not just going to hit, say, first hit, that's it. This is going to illuminate objects all around the scene. You can see that the sphere on the floor, it was obstructed from the bright light coming in through the window by the other objects, but now it's receiving some light that has ricocheted off the wall and come back down to it. And likewise, the blue from the box is now starting to illuminate the wall behind it, illuminate the horse. So I don't want you all to feel bad if the first example that I showed without anything is where your projects end up lighting-wise. I get it. A lot of you are focusing on the way that the data is shown, how the person interacts with objects. But the probes I'm going to show you are some simple ways to add just that little extra oomph. And I hope some of you can take something away. This is my little example scene that I created for this talk. And I'm going to be using this to show off various aspects of light and reflection probes. We're going to start with the reflection probes themselves. Now, when I come into this room here, I have our friend the horse statue, and I put a metal material on it. But you'll notice that it's not reflecting any of the room. It's kind of, there's some real-time area lights above it. Yes, those are showing up. But it just doesn't look that great. I mean, I even labeled it blah. That little gray sphere labeled probe, that is an unbaked reflection probe. One thing I just want to point out, it's getting in the weeds, you don't have to bake all your lighting to bake a reflection probe. You can just throw a reflection probe in and bake it by itself. So when you do that, it will not just improve objects and the way that they reflect the environment, it will also improve lighting and shadowing within your scene. So reflection probes are probably the most important single thing you can add to spice things up. So the next slide is where I have baked the reflection probe. Suddenly you can see a reflection in the actual mirror ball itself. That little gray flat circle is now obviously a sphere. The horse is reflecting the room. And if I just do the flip back and forth again, you'll see kind of a dull room to a more warm environment. It's now reflecting a little bit more of the orange that's on the wall, a bit more of the carpet. So it just feels a little bit more homey. And it's subtle, but even the feet, the legs of the roller chair, which are metal, they've picked up reflection. I'll just do a back and forth again. Crappy? Nice. So this is really, this is like one of the main things I would recommend doing in a scene is playing around with a reflection probe and just baking it and seeing if you can get an improvement on stuff in the scene. There are many limitations though. And some of these limitations they're just innate. When you create a reflection probe or a light probe, you're making a shortcut. And what we're trying to do is fool the viewer into thinking that they're seeing a beautiful natural lit environment where everything's been calculated by the ray every frame, but we're not. We're trying to be a lot easier on the CPU or the GPU. Mitch, if you could play this. I'm sorry, I'm not a PowerPoint expert, so there we go. Here we go. So I'm gonna first select the the reflection probe, and you'll see that it has been baked, it's reflecting the room, and I bring in this other sphere. This sphere is just a dynamic object, it's not part of the static scene or anything. Watch as I move it, the reflection of the chair doesn't get any closer, and when I pass it, there's no reflection of the chair on the right side. It's completely wrong physically. The reason is because this sphere is just taking reflection information from the capture position of the actual reflection probe. You'll notice even when I move it up and down, it doesn't even look like the reflection is, dropping away properly. It's as if this thing is still reflecting from a point just a few feet above the ground. So that's one of the first limitations, is that if you have something that is very reflective and you can see the room and other objects in it, you'll realize that certain things are either not showing up or aren't moving in the reflection. For the most part, this is not an issue. The viewer's eye will just be super convinced when they just see something shiny. Shining keys, dangle. That's kind of the thing that you're going for, is you're just trying to make this not look like a dull object. And the reflection probe goes a long way to making that happen. If I go on to room transitions, Mitch, could you hit this one for me, please? Mitch is awesome, by the way. Tip him well. This room, actually it's 2 rooms, of course, has 2 different light probes in it. Reflection probes. I apologize for messing that up. There are bounding boxes between the 2, and there are 2 different lighting environments. I wanted to show what happens when an object, the same sphere I made earlier, moves between them. You will notice as I slide this that just like before, the reflection doesn't move, you don't see the doorway, it just fades into the other room's reflection. So there it is again, it fades back to the office, and then as it slides into sort of the chill room or living room, you'll see that it just picks up the reflection from inside, but the reflection doesn't move. It is very static, but it's enough to give the viewer the information that they need to be convinced that what they saw was a shiny object move from one room to the other. Or if that sphere were just white, you would see it move, get from the warm lighting environment into the more bluish environment, and it would look pretty darn good. Let's move on. Ben's get it done quick rule number 1. That reflection probe is probably all you need. You can just stop here. I made it up 75%. It's somewhere around, I'd say, 3/4 of the way to being awesome is where you get with just adding a reflection probe. They're not only for shiny objects, but they also help get the color and the general shadowing in your room right. And they're very powerful. Let's move on to these light probes now. Here we have the very crazy network of little yellow balls. Those, I guess each one is a light probe. I like to think of them as probe nodes. That's a weird phrase. So all of these little nodes are part of the general light probe setup, and they all are capture positions. You'll see on the right, I have a green sphere that is not a light probe. That green sphere is a dynamic object, and what it's doing is it is sampling all of the light probes around it, and it's taking the light and color information, which is actually visualized on a baked light probe as it makes a little sphere. And you can see on those little spheres, they're picking up red, blue, light from the floor, and the tops are darker because it's just black space above. But that green sphere, I don't know if it's showing up too well, but you can see it is reflecting a bit of blue light and a bit of red. And that is not going to show up unless you have something like this to fake reflected light. Now, this one is going to use a white sphere, and I'm going to pull it across the floor, and you're going to see it pick up other probes, and its reflected light will change as it moves. Mitch, if you could hit that button. Appreciate it, man. So what I'm doing here is first showing you the nodes around the room. So it's a giant matrix of them. And now when I select the object, you can see that it's sampling these light probes around it. And you can see the reflected light on it suddenly changes to be more red. So in the center of the object, you can also see a little node. That is not part of the light probe node tree. That is actually showing you a representation of the average of all of the sampled nodes. And then that little one in the center is representing what colors will be on the sphere itself. So you can see as it moves around, it pretty convincingly takes on the blues or the reds. Not necessary in many scenes, but for instance, if you got a scene that has like a lava room or something, you want your object to look like it has a bunch of orange reflected light on it. That just gives a nice feel. I'm sure you guys can think of other situations where you really want the surrounding color of your environment to reflect off of your dynamic objects. And this is going to be the way you do it. Now, here is another additional light probe in action, and I'm going to take it through the scene you saw before. There is only one light probe set up in this scene. It doesn't matter if you have multiple reflection probe zones. The light probes you can just throw throughout the scene, and when they bake, they will all just look at their individual environments. They don't really care what the reflection probe's doing. So Mitch, if you could hit this one for me, please. Here we go. I am first going to select the light probes. One thing with, at least in Unity, you cannot put these individual nodes inside of geometry or you're going to get some weird stuff happening. So all of them have been moved outside of geometry. Here, the sphere is starting to move. You can see that its base is reflecting that sort of brownish orange from the floor. What a great carpet color. It's like the 70s. Comes into the other room, and we have the blue starting to reflect up. Now, something interesting happens right here. It samples a node that is above a light. And so that adds to the average. And you saw that that sphere got unnaturally bright at that spot. That's a bit of an error that could be fixed by increasing the density of the nodes. But I think it's a pretty good example of how the averaging works and can sometimes backfire if you don't have lots of nodes close together where lighting is dramatic or color is dramatic. So between the red and blue floor in my previous scene, I make sure there's nodes really close so that it leaves red and it immediately has a new one to pick up. If you have a scene with baked, strong directional light coming into it, like from a sun, and you have a wall that's casting a strong shadow, you want to put some of these probes right inside the shadow and then some right outside the shadow so that your object starts to transition to a darker look as it moves inside. Light probes and their limitations. So these are an approximation. And just like with the reflection probes, you're going to run into some slight inconsistencies that you just can't get away from without going to real-time or ray tracing. Mitch, could you please hit this? Thanks a lot, man. Okay, so first we saw this. We have a sphere. It moves. You see it picks up the red from the floor, picks up the blue. It's doing a pretty good job. What happens if you have an object that spans both colors? So here I move the horse over and you see the same thing happen. It gets bluer on the belly and then it goes, from the red it was red. But here what I'm going to do is rotate the horse around and do some, a little gravitational distortion near a black hole, right? Spaghettification. So what's happening is the center point of the horse is getting the color information, and it doesn't matter that the base is over the blue, it's still showing red. This is because the thing is being averaged from only one place on the object. That center point is now over the blue part of the floor. The entire horse is getting blue reflected light, even up there on the face. So that's one of the things I wanted to point out. There you go. The base is red, even though it's over the blue part. The face is blue, even though it's over the red part. So there are some limitations here. You have to just keep that in mind. In general, though, only some really perfectionist artist person is going to look at that and be like, oh, your reflected light's wrong. This is one of those things that just the fact that you have some reflected light on your objects is going to improve the overall feel of your scene and improve the overall believability. I'm good. All right. This is just sort of a quick overview of what it looks like to actually add light probes to your scene. Mitch, hit it. Oh, I love it. Thanks, Mitch. So here I am. I'm just right-clicking, adding a light probe group. And this is how they initially come in. You get a cube with one of these little nodes at each point. Now, you can stretch. It's not going to stretch the nodes into, ellipsoids. And what I like to do is start in the corners. As you can see, I'm being a real perfectionist here. You can then hit this button to edit the light probe positions, and now each one is individually clickable. You can just hit select, drag, and then one of the cool parts is you can select them and duplicate and move them around, and the light probe as a whole will keep track of which ones they're near and will automatically draw lines to them. This isn't like when you create a mesh and you're actually modeling in a 3D program and you don't want to take like a vertex through, you don't want to take like a face through another face or something. It doesn't matter here. You can pull these in and out and duplicate them and throw them all over the place. So you can see I have some very close transitions right in the middle of the room between the red and the blue. So that was very purposeful, and that is to make sure that as an object crosses that transition, it has an immediate reference to look at. Otherwise, it'll be a little bit muddy. Next one I wanted to show is just the basic operation of when the reflection probe is added to the scene. And just for reference, this is in the HDRP. So if you're in URP or the built-in render pipeline in Unity, you will only have a single bounding box. In the HDRP, you have a double bounding box. Yes, Mitch, please hit the button. Let's make this work. Reflection probe. So it comes in, and it is going to have the gray capture area because it's not baked. Roughly center it in your scene. And then you can grab these, my computer got weird, don't worry about that. You can get these little dots on the side, and you can then move your bounding box. So the only one you're interested in is the inner box. The outer box shows a transition zone where an object will gradually sort of fade away from whatever the reflections are on the inside. And that's a new thing with the HDRP that's pretty darn cool. There's also a button for changing the capture position so that you can move this without changing the position of the box. So this is also really helpful because you might have a certain point in the room where you would rather capture reflections from. For instance, if you capture, let's say this was like a cool glowing map table in some futuristic CIC, you wouldn't want to capture a reflection right above it because it's going to get all this bright light coming up from below, and then every other object in your scene is going to take that information, and even like a desk over here is going to have bright blue light shining up from below, and people are going to come in and be like, what in the world's going on there? So you might want to take that capture position and put it maybe down here to the side so it sort of gets a more even look to it. Ben's get it done quick rule number 2, you probably don't need light probes. I know it's kind of goofy. I just talked about why they're so cool. Mostly, if you're doing a scene with lots of strong color, you want to get a lot of reflected light. That's where the light probes really shine, especially when there's transitions between colors and lighting. When you just have a sort of general room like this one, if this was modeled, a reflection probe would probably be enough. If you really wanted someone's shirt, on a model to look green when they went close to that light over on the wall, that's when you would start putting light probes in the room so that they could capture that color information and impart it on an object that was getting close there. So I hope that this gave you just the sort of barest sliver of a beginning of an understanding of what these two different types of probes do why they're important, how they're implemented, and I hope it gives you enough information to research them on your own with your own projects and not be completely freaked out about them. And also understand why when you deleted your light probes, it didn't really change the scene's overall look. You were probably like, oh, that's no big deal. It's because you weren't looking at the dynamic objects and how they reflected light. Thanks. Yeah. Oh, please. Yeah. Sure. Questions.
So I was at a recent conference, and there was. So I just want to share a fact, and then I want to ask.
Sure. Yeah.
I was at a recent conference, and it was about since the XR symposium. It was a AI VR conference, and they were talking about sort of finding makeshift light probes in a physical environment. In photogrammetry and 3D capture, one uses physical light probes, right?
Yeah.
Shiny balls in a room to check the lighting, so you then can build it into your model to remove the lighting from the thing that you captured and have it lighting agnostic conditions, right? But in augmented reality, if you're placing a 3D object in a scene that is otherwise pass-through video, or let's say pass-through video,
Okay.
so headset. You want to get the lighting correct on your 3D asset that is virtual inside of the actual rendered environment. To do that, you have to have lighting probe sort of information for that virtual object. And they were developing, this was Google, I think they're developing ways of capturing light probe info from like chairs and other objects that might be in the scene, right? So I thought that was really cool.
Yeah.
And I'm just thinking a lot about the physical analog to here. I don't have a question on that yet, but I'm mindful as I'm looking at this, the fact that there's a lot of emerging technologies, particularly for the VR application domain, and a lot of the concerns. You said, you only care about this if you're a perfectionist, but I think the extent to which one needs to be a perfectionist about some design choices, some optimizations versus another, depends on whether you're trying to make it look realistic inside of an augmented reality environment, whether you're doing VR, where frame rate is very important. I presume there's a hit depending on performance hit, depending on how many probes you add. I haven't messed with probes yet myself. I'm very interested now. But I know that a lot of the emerging sorts of things which are alternatives to traditional hardware or traditional representation modalities might disrupt a lot of this. So we've been messing with a little bit with NVIDIA optics, which does hardware-based ray tracing, but is an expensive, for the moment, video card that sits, for the moment, only in a desktop computer and wouldn't be in a standalone VR headset. You've got things like NERF and more recently Gaussian splatting, where the lighting is entirely baked in. So far, those are mostly static scenes, but I've seen some cool recent stuff with Gaussian splatting research that's animated. And I'm just kind of curious. I only see my sort of, I guess, piece of the elephant, and I'm wondering if you are aware of any of those or any others emerging technologies that might sort of disrupt how lighting is handled in use cases, I guess, that are most relevant to AR and VR lighting.
Yeah. I am actually not aware of anything that I feel like is going to be, a disruptor or a game changer. I can imagine things like if you had a headset that had cameras on it to see the environment, if it also captured lighting and color information and then was somehow able to pipe that in as info to an object, that would be pretty cool. I don't know if anyone's doing that.
I have to admit my ignorance. I would presume that the Apple Vision Pro, for example, might be doing that. It's very augmented reality oriented, and it's loaded with sensors.
Yeah.
And I don't know if they're doing that. If you're putting a virtual environment in a pass-through augmented reality scene, you need to be capturing the lighting somehow from the physical environment to make it look realistic.
That's
And
true.
I don't know if they're doing that, and I don't know if they're doing a good job of it.
I can imagine some people kind of faking it by somehow getting a image of the room and then going in and baking a reflection probe like pre-event and being like, well, I know in this conference room it's going to look like this. So then any object we put in a pass-through is going to be lit correctly. I don't know how exactly that would work though. I'm just spitballing here. You got something?
Yeah, so I know it was a pretty big development probably 3 or 4 years ago when Pokemon Go was big. Because originally Pokemon Go, it was just like, here's my Pokemon, just slapped on top of some video. And then there was developments, especially amongst the Google's AR team and Apple's AR team, to actually sample. So it wasn't a full capture of the room, but they would sample the video, and as you would move it around, it would continue to sample the video to get more light probe type data, so that as you added models, that they would take on some of that lighting. So it wouldn't be a reflection probe because that gets weird.
Yeah.
But yeah, so they're doing some of that. I don't know about the Apple Vision Pro specifically, but I know that that is within Apple's wheelhouse. So.
Cool. That is cool. Yeah. I love this stuff. I usually just live in this frustrated little bubble of like, why isn't this working? So, anyway, learning through failure. Very important. Anyone else? I know this is a bit esoteric and out there for most of you, but okay. Thank you very much.